Hello, here we are again with Pre-Calc Lesson 98, Change of Base, or COB, as I'm going to call it, and Contrived Log Problems. I'm so excited about COB. I think it's the lesson that we've all been waiting for. Change of base, what does that mean? It's for logarithms. It's what we do when the base is not 10 or e. Okay, how do we figure things out if we have a base that's not 10 or e? Is we can use the change of base formula and rewrite it as a base of 10 or e. Let me show you how with this example. We have the log base 5 of 15. I can rewrite this change of base formula as the log of 15 over the log of 5. I can do both of these in my calculator because it has a log base of 10, and this gives me 1.68. Change of base formula, which means 5 to the 1.68 equals 15 if I was to rewrite this in exponential form. That's change of base. You rewrite the log of the argument over the log of the base. You've now changed it to where you can solve it in your calculator. And if you have a fancy calculator that you can put in any log you want, I don't care. You don't get to do it that way. You have to use change of base. Let's do another example. Change of base. So easy, so fun. Log base 7 of 82. You don't know what that would be. 7 raised to some power is 82. Gee, that seems really hard. But we can rewrite it as the log of 82 over the log of 7. Oh, which gives me 2.26. So 7 to the 2.26 is 82. Go figure. So easy. Let's move on to contrived log problems because that was so easy. Okay, remember rules of log problems. Exponents can be pulled in front of logs, right? That's our power rule. Okay, we rewrite exponents as logs, and we also rewrite logs as exponentials. So let's do some examples, get some good practice. We are going to solve the log of x squared equals the log of x squared. All right, so I'm first going to rewrite this side. I'm going to bring the 2 to the front as 2 log of x equals, I'm going to leave it as the log of x squared. Okay, now I'm going to rewrite it again. I have 2 log of x equals the log of x times the log of x. What I can do is we're going to first assume that log of x does not equal 0. And we know that to be true because we're going to divide by it. So I'm just excluding the case where that is 0. Okay, so I divide both sides by the log of x, and I get 2 equals the log of x, right? It cancels on both sides. If I rewrite this in exponential form, I get 10 squared equals x, so x is 100. Now, that's not our only answer because we have to think about the case where the log of x is 0. Okay, the log of x is 0 if we solve this. That means 10 to the 0 equals x. 10 to the 0 is 1, so x equals 1. If I plug that in here, if I have 2 log of 1, does that equal the log of 1 squared? So 2 times 0, does that equal 0 squared? Yes. So x can also equal 1. That's like my, the case I have to always be aware of is when x equals 1 in this situation, okay? Let's do another example. If I have log of the square root of x equals the square root of log x, okay, we know that the square root of x, I can rewrite this as the log of x to the 1/2 equals the log of x to the 1/2. I bring my power in front, so I get 1/2 log of x equals log of x to the 1/2. Okay. Now, I can get rid of this exponent by squaring both sides. So I get 1/4 log of x squared equals the log of x. And now I'm going to bring my log of x over, so I get 1/4 log of x squared minus the log of x equals 0. I'm going to factor out a log of x. So the log of x times 1/4 log of x minus 1 equals 0. Just like when I have a quadratic equation and I factor it, now I have two mini equations. Either the log of x equals 0 or 1/4 log of x minus 1 equals 0. So I solve this. 10 to the 0 equals x, so x is 1. Here I bring the 1 over, so I get 1/4 log of x equals 1. So the log of x equals 4. So 10 to the 4 equals x, so x is 10,000. And those are the two answers to my problem. What? All right, let's keep going. It's just reusing logs in a different way than you've done before. We're going to solve the log of x equals 3. Bum, bum, bum. I'm going to rewrite this in exponential form. There's still a base 10 here. So 10 cubed equals the log of x. 10 cubed is 1,000 equals the log of x. So if I rewrite this in exponential form, I get 10 to the 1,000 equals x. Now, please don't write out all those zeros. Just leave your answer like that. Save all of us a headache. Let's do one more. Why not? We've already stretched what we know about logs. Let's stretch it even more. X to the square root of the log of x equals 10 to the 8. Okay, so I'm going to rewrite this. X to the log of x to the 1/2 equals 10 to the 8. Okay. Now, I can take the log of both sides. I wrote that. I want to write that here. So this gives me log of x to the 1/2 times the log of x equals 8 log 10, which we know that this is just 8. And here, if I have two things of the same base being multiplied, I add their powers. So I get the log of x to the 3/2. Then, to get rid of the 3/2, I can raise both sides to the 2/3. So I get the log of x equals 8 to the 2/3. We should know that by now is 4. Rewrite this in exponential. 10 to the 4 equals x. So x is 10,000. Okay? We are totally reworking what we know about logs right now. Isn't it just thrilling? I hope you find it as thrilling as I do, and if you don't, you may go take a nap to help with your headache. Because that's all for Lesson 98.